Hi guys, welcome to today's video. This is 2019 paper 2 question 9. Standard geometry question for 55 marks. Great practice. This comes up every year, just looking for different lengths and the radius and so on. So let's get into the video. Okay, so here's our question. We're given a triangular patch of ground, SGH, and the two side lengths SH and GH, as well as this angle here. And the circle on the inside is the incircle of this triangle SGH, which has center P. So the first thing we're asked to do is to find SG, which is the third side, and to give our answer correct to one decimal place. Okay, so basically we're going to be having to decide here whether we use the sine rule or the cosine rule. And the way I always learned it is if you have the length of two sides, so like this with the angle in between those two sides, you use the cosine rule. And if you have basically anything else, you use the sine rule. So you're going to need at least two sides and two angles regardless, but it's just about what you have. In this case, we're going to be using the cosine rule because it fits this description here, where you have a side, which is 30 in this case, and then the angle, and then the other side, which is 58. So I hope that makes sense. And the cosine rule can be found in your log tables, so you don't have to remember that, and it's just going to be here. So now all we've got to do is pick out our sides and our angle. So in this case, we're looking for the side a squared. We have the sides b and c, and a is just going to be the angle we have, which is 68. And it's very important to note that the angle a is always going to be opposite the side a. So sometimes you're going to be looking for the angle, and other times you're going to be looking for the side, but you always have to make sure that you set it up so that a is opposite capital A, the angle. So once we plug in our values from over here on the right into the cosine rule, we're just going to have actually SG to be squared, equal to everything on the right hand side. So now we're going to just square out our 30, our 58, and also simplify this a little bit. So our expression here can just be expressed as numbers once we square it out. So we're just going to turn that into one number now, which will give us SG to be squared is equal to 2960.369. And the square root of that is going to be 54.409, which to one decimal place is going to be 54.4. And remember to put in your meters as well. So that's part A. One thing I'd be careful about is removing too many decimal places from the end of this number here, because they have asked us to do it to one decimal place, so it has to be pretty precise, and you really should be careful about taking too many things off the end of that number. So besides that, it's a very standard part A, and it's going to be worth 10 marks. So the next thing we're asked to do is find the angle HSG, correct to two decimal places. So if we look at our diagram, that is up here. So given what we have, which is an angle and three sides, because we found GS to be 54.4, we can use the sine rule to put the sine of 68 over 54.4 equal to the sine of our unknown, which we're going to call x, over 30 over here. So in case you ever forget, the sine rule is just here in your log tables, and one handy thing you can do with this is just flip it if you need to. So a over sine A being equal to b over sine b is the same as sine A over a equal to sine b over b. So that's actually what we're going to be doing here, because we're looking for an angle rather than a side, and it's easier to have the angle on top on the left hand side. So now we have all the information we need, and we're just going to plug everything into the equation. So sine x over 30 is equal to sine 68 over 54.4, and we're just going to multiply across by 30. So we now have this expression, and we're just going to plug everything into the calculator, so that way we don't lose any decimal points or anything in the process. So we have 30 sine 68 over 54.4, which is equal to 0.5113. And another tip is to always make sure that your answer is between 0 and 1, because the sine of any angle that could show up in a triangle is always going to be between 0 and 1, so it meets that requirement. So therefore the angle x is just going to be equal to the sine inverse of 0.51131. So we're going to go shift sine 0.51131, and our answer is 30.7511. which to two decimal places is just going to be 30.75. So that's part B. Nothing too tricky, just a standard use of the sine rule. And you've already used both the cosine rule and the sine rule so far in this question, so definitely good for revision. And for getting all of this out, you're going to get 10 marks. So part C asks us to find the area of the triangle SGH, to give our answer in meters squared and correct to two decimal places. So here's everything we know about our triangle so far. We found the side SG and the angle HSG. So we actually know the value of this angle over here just by subtraction from 180, and that is equal to 81.75. So the formula we're looking for in our log tables is just going to be here, the area, a half AB sine C. So we can essentially choose any two sides, and then the angle that isn't opposite either of those sides. So I'm just going to choose the sides 30, 58, and the angle 68. And I'm doing this because that's just us dealing with whole numbers, and that's much easier than choosing any other combination of angles and sides. But I just want to make it clear that whatever angles or sides you choose, it should work out roughly the same. So using A equal to 30, B equal to 58, and C is equal to 68 degrees, we can form this equation for the area on the left, which we're just going to plug into our calculator as a whole. So when we plug all of that in, we're just going to get 806.6499, which corrected 2 decimal places is 806.65, and that's in meters squared. So another very nice part of the question, in my opinion, and believe it or not, just for that you're going to get 15 marks. So clearly very worth revising. The next part of the question, D part 1, asks us to find the area of the triangle HSP in terms of R, where R is the radius of the helicopter pad. So the first thing we're going to do is go back to our diagram and then draw this triangle HSP. So that's what it's going to look like. Just picture those as being straight lines. So the key thing to realize about this part of the question, or I should say the thing that they want you to realize, is that this line of length R is perpendicular to the side HS. So therefore the perpendicular height is R. And something you should know from junior cert is that you can find the area of any triangle using the formula half times the base times the perpendicular height. And in this case the base is going to be 58. So given that, we're just going to have to simplify that a little bit. And it's just going to be 29R. And that's once again in meters squared. And that's actually it for D part 1. A very short part, just based on that one key realization of how exactly to approach it. And for D part 1, you're going to get 5 marks. And for D part 1, you're going to get 5 marks. Next, we're asked to show that the area of the triangle SGH in terms of R and can be written as 71.2 R meters squared. So if we go back to our diagram once again, it's clear that they want us to do something similar to what we've done in D part 1, which was to draw a line from P to each of the vertices H and S. So we're going to do the same thing now to the vertex G. And you'll notice when we do this that we have 3 triangles, and they are HPS, GPH and GPS. And we just established that the triangle HPS has an area half times 58 times R, which is a half times the base times the perpendicular height. But we can actually draw another line here in this triangle, which has length R, and the same thing for the triangle here on the left, again with HR, and the same thing for here on the left, this triangle, which again has height R. So GPH can be written as a half times 30 times R, because we have base 30 over here, and GPS is just a half times 54.4 times R, because our base over here is 54. And now because we have the area of this triangle here, as well as this one on the left, and the one up here on the top, we actually have the whole area of the triangle GSH, which is what we're asked to find. So the key is just to add these 3 areas together, and that'll be our answer. So therefore our area, as I said, can be represented as a sum of these 3 things, which simplifies to 29R plus 15R plus 27.2R, and that was simplified to 71.2R, which is what we were asked to show. And that means that is it for part 2. And nothing too tricky there, just applying the rule we learned in D part 1 to 2 other triangles, and for doing that you're going to get 5 marks. D part 3, we are asked to find the value of R, to give it in meters, corrected 1 decimal place. So this is very, very easy because we have 71.2 times R, and we already found the area of SGH earlier in the question. So the area of SGH we found was 806.65 meters squared. So therefore we have 71.2 R is equal to 806.65. So R is equal to 806.65 over 71.2, which is 11.3295, which is 11.32935. But we're going to put that to 1 decimal place, so it's just 11.3 meters. And that's it for part 3, which was very short, and that's going to be worth 5 marks. Part E tells us that ST is a vertical pole at the point S. The angle of elevation to the pole is 14 degrees from the point P, which is over here. We're asked to find the height of the pole, correct to 1 decimal place. So clearly TS is perpendicular to SP, which means that the angle of elevation, which we know is 14 degrees. So we know this angle 14 degrees is opposite the side TS. And inside a right angle triangle, that tells us that sine 14 degrees is equal to the opposite of the hypotenuse, which is TS over TP. But in this case, I think it's easiest not to use sine. In fact, I don't think you can use sine because we want to use the side PS as well as the side TS, because we can actually find the value of PS, whereas TP we can't find the value of at this point. So in order to find the side PS and then use that, we're going to have to pick tan. So we're going to have tan 14 is equal to TS over PS, and of course TS is what we're trying to find, so now we're just going to go back up and see how we can find PS. So if we go back to our diagram, we have this blue line here, which is PS, which we drew, and straight away the thing that jumps out to me is that This is the hypotenuse in a right angle triangle. And we know 58, and we found out that r was equal to 11.3 meters, which means we can find PS using Pythagoras' theorem. And you can also use the sine rule with another triangle or whatever you want to do here, but I think Pythagoras is just handy. So in that case, PS squared is equal to 58 squared plus 11.3 squared. And 58 squared plus 11.3 squared is 3491.69. So if we go back up to our diagram, we have this line here, PS, which we drew earlier. And the easiest way to find this line is to use the sine rule. Now, the first temptation is to use Pythagoras with this line, which is 58 meters long, as well as r, which we found the value of. But we actually don't know the length of the line from here across, because 58 is the entire line HS. So that's not going to work. So if we go back up to our diagram, we're trying to find PS, which is this blue line we drew earlier. And the easiest way to do this is to recognize that because we have the incircle of the triangle GHS, the line PS actually bisects this angle over here, as well as the other two angles, which means that we know the value of this angle here is just going to be half 30.75, which is 15.375. So the sine of that is going to be equal to r over PS. So the sine of that angle is going to be equal to r over PS, or the opposite over the hypotenuse, which is PS. And I think that's probably the easiest way to do this. You could mess around with the sine rule or something like that as well, probably. But they've done it this way, and it's perfectly fine, and probably the easiest way to do it. So we said that the sine of the angle PSH is equal to r over PS, and PSH is equal to a half 30.75, which is 15.375. So therefore our equation is going to be sine 15.375 is equal to 11.3 over PS, because the radius is 11.3. So PS is equal to 11.3 over sine 15.375, which we're just going to put in our calculator. So therefore the value of PS is equal to 42.6197, and that means tan 14 is equal to TS over 42.6197, and we got that from up here, which we set up in the beginning of this question. So TS is equal to 42.6197 times tan 14 by multiplying across by what's underneath the fraction, and using the calculator again, the value of that is 10.626, but they've asked us to put it correct to one decimal place at the start of the question, so we're just going to round that off to 10.6. And that's the end of part E and the end of question 9. Quite a nice question, I would say, compared to the other questions in this paper, which were, I think, a little bit tougher. But that's it for this video. I hope you enjoyed it, and if you did, there's going to be other similar videos in the description, as well as some other helpful resources, and I'll see you next time.